Hi, this is Dr. Emenacker. This is going to be a short video, and all I want to look at in this video is where did the quotient rule for computing derivatives come from anyway? With the chain rule now part of your repertoire, we can take a look at where the quotient rule come from. So let's start at the first line on this and take a look at how this unfolds. If you recall, with the quotient rule, you start out with a situation where you have y equal to a function divided by a function. So you have something like this. It can be written in this second form where g has an exponent of -1 since it was in the denominator. Okay. Now that we have this, what we are set up with is one function times a second function. Well, wait a minute, that sounds kind of like the product rule. And in fact, it is. What we're going to have is our first function's derivative times the second one plus the first times the derivative of the second one. So that's what's going to happen here on this next line of computation is we're going to apply the product rule. Okay, so when we apply the product rule, we're going to get the derivative of whatever f is. So that's going to be f prime. Then we just copy down whatever g is. Well, that's g to the -1 power. There's the first half of the product rule. For the second half of the product rule, we take the first factor times the derivative of the second factor. Now, the derivative of this second factor is something we were not able to do until we mastered the chain rule. To take the derivative of this second factor, recall, you're going to bring this exponent down front. It's going to become a coefficient. And in fact, I kind of squeezed it in. It's right there, the -1. Then you're going to take and subtract 1 from the exponent. And when you subtract 1 from the exponent, -1 minus 1 is going to give us a -2. And the inside function is going to just carry along as is, unchanged. That's the first part of the chain rule. The second part of the chain rule then says, okay, now that we've dealt with the derivative of the outside function, we need to take the derivative of the inside function, which gives us our g prime. Okay, the next step is purely algebra. In fact, the rest of this is purely algebra. From here, I'm going to rewrite this first term with the g of x back in the denominator, which is really what g of x to the -1 means. Then I'm going to rewrite this second term being mindful of two things. First, g of x to the -2 right there goes into the denominator. That's what the exponent with the negative means. The second thing, and this is the easy one to let slip by, there's -1 there. I'm going to bring that out front, which makes this minus this second term. So what I now have is a situation where I have the first term minus the second term. Okay, so I have my f g prime over g of x squared. At this point, we have two fractions. If we want to combine them, we need a common denominator. Well, the first fraction has a denominator of g of x. The second fraction has a denominator of g of x squared. That means our common denominator is going to be g of x squared. To accomplish that, all I'm going to do is take the first fraction, this one, multiply it by g of x over g of x, which will give me g of x squared in the denominator. But look what now results in the numerator. I have my f prime of x, and the numerator also has to be multiplied by g of x. So we wind up with here is f prime g over g of x squared minus f g prime over g of x squared. So at this line right here, I now have a common denominator. Can combine those two numerators over the common denominator, g of x squared, and what we wind up with here is f prime g minus, the minus, not a plus, f G prime, and there's the quotient rule. The quotient rule comes from a combination of the product rule and the chain rule. Now, there are other ways to derive it as well, but this is probably one of the more straightforward ways.